Welcome to today's webinar. We're going to be talking about how to use RoadEng with Softree Optimal software for wind farm road network design. My name's Erin. I'm one of our resident webinar hosts here at Softree, as well as the business development manager. And with me is our training manager and our colleague, Matthew Dickey, and he's going to be handling all of the heavy lifting in today's presentation. Now, wind farms present a really unique challenge. They often require construction of a large road network. They're heavily cost constrained, and they have a need for quick planning and analysis to determine if a site is even feasible. So today's webinar is going to focus on a workflow inside of RoadEng to help tackle all of those requirements. If you are joining us from another industry outside of wind farms and renewables, whether that be mining, forestry, or any other folks working with rural roads, a lot of the concepts that we're going to cover in today's webinar are definitely applicable to your projects. Perhaps just tune out the part where we talk a little bit about pads and crane laydown areas. So in terms of a little bit more of an agenda and some details on the project, we're going to be working on a smaller wind farm site that includes 3 turbines and their pad and crane laydown areas. We're going to be designing the road network that connects them and optimizing the earthworks. As I mentioned before, we are going to be leveraging our full package or full software. So this is RoadEng with Optimal, and we're going to be using this soon to be released version called version 11. And in that, we've got a couple really exciting new optimization tools that make this process a whole lot easier. So those 2 optimization steps we're going to be looking at are one of them is done in each of our modules. And if you're new to RoadEng, it's a modular program. So we're going to start in the terrain module. And in addition to a whole bunch of steps to get us set up with a model, we're going to be using our A to B optimization, and we call this Path Explorer. So this is going to help us find those preliminary high-level locations for our roads and how they connect between the different turbines. And then once we've got that sorted, we'll head over into the other module of RoadEng called Location. And this is where we can use our other detailed vertical optimization tool. And this is going to help us fine-tune our profile, reducing the earthworks by minimizing the construction costs, so the cut and the fill, as well as the movement costs for those materials along our alignment. So that's kind of our 2 major optimization steps you're going to see in our workflow today. In terms of a format to the attendees in the live version, you are all muted and you are going to stay that way, but we encourage you to ask questions at any time in the presentation. You can just type them into that question section of your GoToWebinar panel. And we're going to be jumping a little bit back and forth between Matt and myself, just so we can really make sure we stop, introduce the next step in the process to keep it nice and clear. So with that, our very first step in today's workflow starts in our terrain module, and it's all about making a terrain model. Here, we're going to import the survey data. This is our topographic data, as well as some other spatial data. So we've got turbine locations. We're going to bring those in as shape files. And we can also import other data such as streams and other formats. And then we're going to generate our tin surface. So with that, I am going to pass control over to Matt. And we'll get started on step 1, making the terrain module.
All right, perfect. So as Erin said, we're going to start in terrain, and I'm going to click the terrain icon. And I'm going to click Insert File. And I'm going to navigate to the data that I'm using for my topo surface. So just quick note, we work with a bunch of different formats. LiDAR is a big one, DEM is a big one, and then conventional survey data or data from other programs. Support them all, and today we're using a DEM file, so a TIFF. So I'm going to bring that in. Now, one thing about the TIFF is we have an option to create a 3D model right on import. I'm going to roll with that, and our projection is carried forward with that. So I'm going to just let that get read in. So I've got my plan view over here, not very interesting. If I wanted contours, I'd come over here and I'd generate my contours. Or if it was a different format of data where it wasn't creating the tin on import, I would calculate my triangles for that tin. But I'm gonna do something I don't normally do, and I'm gonna do my project today without contours. I'm gonna rely more on the 3D view. I'm gonna bring in some additional spatial information just to help keep track of what's intended to be where, and we'll come over here, we'll click Insert File. I've got a shape file with some streams we'll bring in. I'm just going to change the color of those because streams should be blue. And I'm going to bring in the proposed locations for the turbines. So in this case, we're told we want to put turbines there. Oh, just so we can see those, I'm going to change my symbol. I'll also change my 3D symbol just so they're easier to see. So we've got 4 proposed turbine sites. And with that, I'll hand it back to Aaron.
Excellent. We're going to get smoother, I promise, at the screen transitions here. So our next step in this workflow, now that we've got our tin model created from our data, we have 4, not 3. Sorry, I mixed up on that one, guys. Turbine sites added. Now we're going to go and create some features for our rough pad geometry. So we're looking to get the pad geometry and shape, make sure we've got the orientation sorted, and we're going to include these inside of our terrain model. So with that, step 2, back to you, Matt.
Alrighty. All right, so this, I'm going to bring in and kind of plan the orientation of my pads. Now there's a bunch of different ways we can tackle this. I'm tackling it one way, and it might not be well, super intuitive why I'm doing it this way to start, but well, I'll try to explain it as we go, but it's going to be more apparent when we get into location. So what I did is I just, rather than clicking in the shape of these proposed pads, I've got some geometry that I reuse, and at least as a starting point. So I'm going to bring those pads in, and I'm going to, well, that's my proposed turbine site, and we'll move those to where we'd like to be. So I'm going to, I'll try not to just use quick keys because I can be bad for that sometimes, but I'm moving that pad geometry that I've just brought in. We're going to get it closer to our data set. And we'll just set that there for now. So let's take this here. Now I'm going to want to refer back to that. So I'm just going to paste it. And I'm going to grab just this one here. I'm going to pull it over here. And I want to, well, I've got my proposed pad relative to the turbine site. I'm going to hover here and see that, well, we're at an elevation of 142. So just to make sure it's a little easier to see, I'm going to shift this up. And what I'm doing here is just focusing on the orientation. So I usually want my pads to be fairly flat. So I'm going to try and get this kind of orientated to side hill, just so I don't have a portion of that taking a bunch of cut or fill unnecessarily. So this process is kind of one of those things that it's a chicken or an egg scenario. well, we're gonna try to get a road from this existing road up to there. So if it's the orientation of the pad that dictates where the road goes, then we'll usually do our pad first. If we're not sure how we're gonna get there, well, we'll do the road first and then rejig things around. And you're not stuck with just doing a linear workflow. You can adjust things afterwards. But yeah, we're starting with our pad here. Now I'm gonna do the same for these other ones. I'm just copying this rather than moving the original around because I want to be able to go back there and reuse it. So same thing, I'm going to just use the hover tips. So that's about 150 meters elevation. I'm going to shift this up from 0 just so I can see roughly where we're at. And I am not opposed to that. So I've just copied. We'll continue right along here. And we're going to turn it a little bit here. Just assume we're going to tie these all along the same road. Yeah. And just to reiterate, I'm not worried about the details at all right now. I just want to get that orientation to be reasonable. And then I'm going to figure out the elevation, the grade, the crossfall, all that as I design my road so I can incorporate the earthworks and share material movement from pad to pad. So once again, I'm going to just copy that guy, paste, and we'll move it towards this other one. The nice thing about this project is it's fairly benign once we get up on top of this ridge here. And just 132, I'm not going to worry about the details, but just it's going to help me gauge whether that is reasonable. Sure. So I've got my pads tentatively set up. I may have to make adjustments once we get into the details and see how we interact with our road approaches. But yeah, we'll go on to the next phase. So.
Awesome. So the next step in this process, now that we have our terrain model created, our pad orientations sort of set up, is really to do that first optimization step, and is our last step, I should say, inside of the terrain module. Reminder, RoadEng is modular. So this is Path Explorer. We're going to take a look at it. It's probably our most exciting new feature coming in version 11, and the reason why we're playing in beta software today. So we're going to leverage this to help us determine the most suitable locations for these roads between the turbines. We can do it, I think we're going to do it initially without constraints, and then we're going to constrain it a little bit to be a bit more indicative of the conditions of our project. And with that, I will pass it back to Matt.
Cool. All right, so I'm going to, well, I know I want to go from the existing road down in the valley bottom, and I want to get to my first turbine. So I'm going to create a new feature. I'll make it draped just so we can see it. So I want to start my road say there. And I want it to end up here. Now again, I'm going to not account for some things that may be pretty obvious to start, but we'll just see where this puts it. So going into our Path Explorer tool, I'm going to select the feature that I've just created. So I want to figure out A to B based off of that feature. I'm going to put in my design parameters. So I want a minimum 50-meter radius curve. I'll mess around with stuff like my resolution if I want to increase or decrease my resolution. Next rule of thumb is divide your curvature by 4. And yeah, I'll change my grade and I'll go max grade of 18%, and I'll change my unit costs. We're basing what's the best route based off of our earthworks, minimizing our earthworks. I'm going to say earthworks costs, I should say. So I'm going to say I expect to pay $4 a cubic meter for cut, $6 a cubic meter for fill, and then I'm going to have a surfacing cost, which is going to account for my graveling and shaping that road top. We'll hit OK. And for the sake of being interesting, I kind of hope it's not phenomenal. So I've told it to find 5 options, and it's found 5, but it's looking for better solutions. And we're going to let this run until it tells us that it's unlikely to find, unlikely to improve further. So I'll hit cancel. And there we are. Now there's a few things that I don't like right off the hop. Well, this approach might be reasonable, the green line. These others aren't going to be much good to make the corner to get onto that pad. So I want to constrain my approach angle. Same with my start point. So for this, the highway's down here. So I don't want to have a crazy corner and have to grade out. I'm going to just go for something that's nice meandering bend. So I'll constrain my approach angle. And then as we look at this a little closer, we've got these streams, and yeah, putting the road right up the middle of a stream probably isn't ideal. So we're going to add some additional costs. Now I'm going to add a no-go because I don't want to have that cross right at where the streams junction anyway. So I'm going to make a no-go area here, and the other streams I'm going to just weigh the expected cost to cross them. So add an additive cost into my unit costs. So this stream here, I'm going to change my name so I can keep track of it. So I'm going to say that's going to be $2,000 to cross that one. I'm going to say this guy here is probably $4,000. And this guy here is probably, well, it's a biggie, so we'll go 10. And then, like I said, I don't want to mess around with this kind of lower reach where the two streams meet. So just to deter that altogether, I'm going to say that's a no-go. All right, so we are going to add construction zones. We're going to come in here and we're going to say, well, let's create a new no-go polyline. So that's that one that I just called no-go. I'm going to say, well, let's make some polylines that cost a bit more. So our $10,000 one is going to have an additive cost of $10,000 per square meter for crossing. And we'll do that and we'll set, well, our 2,000 is going to be, you guessed it, 2,000. And our 4,000 is going to be 4,000. We'll just see. So I've got 10, 2, and 4. That's good. Next, I'm going to continue along with what I had. So current features selected here. Our construction zones, which we've just defined, are assigned there. And we'll go in here and we'll say, well, at the start of this, I want it to only come from this direction. And at the end of this, well, I want it to just come from that direction. Everything else we'll leave the same. I've got remove existing features turned on. We'll hit OK. And again, I've got that number of options set to be 5. And it's thinking away. Shouldn't take too much longer, but we'll see. It's one of those things that's solving there we go. Unlikely to improve further. And there we are. So we can see we've hemmed it in. Yeah, it's looks like all the freedom to choose different approaches is really just comes down to where we end up crossing that stream and what side of this little guy we end up going on. So we've got our Path Explorer tool run. I'm going to hold off on running it for these ones, just, well, 2 reasons. One, I'm going to use it as an excuse to just show a traditional design after. But the other thing is that it's fairly easy to choose where to put the road when you've only got a few hundred meters between things. So back to Erin.
Excellent. So now that we've got a terrain model, we've got our pads, orientation and geometry, and we've got some initial locations from a high-level optimization, the next step within RoadEng for workflow is to go over to the other modules. This is the location module. And here we're going to start a new project and reference that terrain file that we just created. And with that, very, very brief intro, I'll pass it back to Matt.
All right. So one thing I did there that just while Erin was talking, I saved my file. So I hit save, and we're going to reference what we've just created when we go over to location. So we'll click New File. We're going to browse that topo. So that one there. And I'm going to just choose an initial alignment that's just a single point. So I'm going to trace those lines in that we've just created in terrain. And a footnote there is later versions as we approach our final release for version 11, we'll have that set up. So it's going to bring it in as a proper alignment. Now we could go with this. That's going to be a polyline, so I don't want a bunch of vertices on each segment around those curves. So I'm going to just trace it. We'll click that there. And we're ready to dive into the kind of the detailed design side of things. So back to you, Erin.
I needed to unmute. So the next step is setting up your cross-section template. And so a cross-section template is kind of like a mini program inside of RoadEng. It allows you to control what your typical section looks like, including ditching. And in our case, it's going to allow us to include a special component developed specifically for wind farms, which is called the Pad 4 component. And this is going to connect that pad geometry that we set up inside of terrain to our road and allow us to do greater earthwork optimization that includes the volumes and materials that are being used in those pads and laydown areas. So I'll pass it back to Matt. He's going to step into the cross-section template editor, and we are going to look at how to set that process up.
All right. So I'm going to just move this starting point here to, and we'll worry about our alignment later, but I'm just setting it within the confines of this proposed pad location. So to start, my cross-section geometry is the default civil cross-section geometry when you install the software. And this project, I want it to be a gravel road. So this kind of rural highway cross-section geometry isn't super appropriate. So I'm going to change that. And then, as Aaron said, I'm going to include the geometry of our pads in our cross-section geometry here. So we're going to go up to the template editor. And, well, what I'd like to use as a basis is closer to our resource low volume road. So I'm going to start by just copying that over. And I'll give it a unique name. And before I add anything special to it, I'm going to just make sure my dimensions are appropriate for the road portion. So I've got a 3 meter width on my left side, so total width of 6. That works for me. I'm going to change my surfacing. I'll go with a 6 inches or 15 mils, and I'm going to change the fill slope of my surfacing here to be, let's go 5:1, give them a bit of a shoulder. We're going to, rather than doing the same on the other side, we'll just copy and paste that. And rather than tabularly assigning the geometry of this pad where it changes fairly frequently, we're going to go on here and we're going to get a template that has some smarts built in. So miscellaneous components. So I've got this one here. I'm going to copy that. I'm going to bring that up here. So I'm going to just leave that on the side. And same as before, well, I'll probably want to change some things like, let's go with a thicker sub base. And this part here is the thing that might not be obvious. So I'm going to set that width to be 0, but if we're within a set distance of a pad, I want it to go out and find that pad edge. So I'm going to say, well, let's look at our topo surface and let's look for any of our features that are called pad limits. So that was the feature name of those pads that I moved into place. And we'll click our drop down. And now we can see that that's going out to where that pad edge is going to be. So we'll do that, and I'll do the same on the other side. We'll hit OK. And nothing changes in our design, and that's because we created a new template that hasn't been assigned yet. So we're going to go assign by range, and we're going to assign this wind template. And now we can see it's taking on the geometry of our site. And if we go somewhere like that, it's getting narrower as we go down to the different segments. So that is setting up the template that I plan to use for the bulk of this project, and we'll send it back to Aaron.
So the next step in our workflow really is the alignment, design, refinement, and we're going to lump in detailed optimization into here as well. So when I pass it back to Matt, he is going to create that initial horizontal alignment by tracing the existing ones. He's going to add curves, fine-tune his design, as well as leverage our vertical optimizer to minimize the earthwork costs of that profile. So it's going to take all the little cuts and fills, attempt to balance them, as well as looking at it from a material movement standpoint and minimizing those movement costs. So a lot in step 6. So Matt, back to you.
All right. So yeah, there's going to be more talking here and longer between switching back and forth. So like I mentioned there previously, the plan is to have this first thing that I'm going to do just to be done automatically, where we've got the geometry from those features we've created using the Path Explorer tool. Oh, and actually let's, rather than just guessing where we're at, where I don't have contours in that plan view, we'll look at this. So I'm going to go along here, and if we wanted to, we could look at the weighted results of which one was said to be cheaper. I'm going to really pick which one I'd like to follow based off of, well, where I'd like that crossing site to be. So getting a little qualitative with things rather than just following the numbers, but I'll go with that middle option. And the nice thing about having that line in there is I don't really have to have too much for judgment. I'm just looking at where things are at. So I've got the tangents largely defined here. I'm going to add in my horizontal curves. So I can come in here. Now I know I've set those to be 50 meters. So when I ran Path Explorer, so rather than clicking in each one, I'm just going to use my default curve. And we'll see how good I was at tracing tangents there. So pretty close. We'll nudge a few things in. So, and everything is updating. We can see our topo surface underneath things. And of course, we could design that profile by hand. And I will here later for the kind of the conventional design side of things. But let's use our vertical optimization tool. So like the Path Explorer tool that we were using at the start, it's all what we consider to be best is going to be driven by costs. I've got my ground types. I've got just the default overburden assigned for this thing. And let's go 4 and 6 for our handling costs. Now, if I expected to go through shallow bedrock or different materials, I could assign different costs and different materials. I'm going to just keep it simple with 1. And we're going to include our material movement costs here as well. So the actual cost to haul that cut material back and forth and use it as fill. So we're going to set all these parameters up in our tool here. So we're going to go vertical optimization. We're going to tell the software to sample along our alignment in 20 meter intervals. We're going to say, well, actually, I'm going to keep track of one thing. Okay, I want to know that number because I'm going to change my design specs when we get into the pad. So standards, I'm going to say, well, we can go up to 18%. We can go as low as 12% adverse. I'm going to just use fast curves, which allow my curves to be butted up against each other. They give the cheapest possible solution. And we'll apply that. But for that last little bit from station 1038, I don't want my pad to be on an 18% grade with a big curve through it. So I'm going to say, well, let's keep this linear and let's keep this pad on a max of a 2% grade. Other things we can do here is at the start, we'll say, well, let's add a control point of the start. And there's other things that we can take in, all sorts of considerations like material movement constraints, side casting, full bench, pits, etc. But we're going to just leave that as is, and we'll let this figure out our vertical. This is just going to take a moment. And there we are. We've got the cheapest solution right now. So according to the unit costs that we've put in there, do our earthworks, we're at $131,000. Keep in mind if those numbers seem out of whack to you, well, it's a product of my geometry and the site, but and more importantly, if you're paying different unit rates, you can change that and the cost will scale. Nice thing about this is in order to get a reasonable vertical, your costs don't have to be exact. It's going to want to minimize cuts and fills and minimize the distance that it gets moved. And then I'll just take it a step further with another version 11 feature. We're going to just simplify our alignment. So instead of just having all these curves to get the absolute cheapest solution, we're going to group some similar curves together and get rid of the ones that don't really add a lot of value. So there we go. We've cleaned that up, and we're still very close to the balanced solution, but we'll take it a step further again, and we're going to use those cleaned up curves to dictate our geometry. So, and that'll just take a moment, and then I think I'll let the screen update here after it's done thinking, but then we'll get back into it. So there we are. That's the cheapest, so not much of a difference from what we just had, but yeah. And it cost us a few $1,000, but a lot less curves. It'll be easier to lay out. Or we could just rerun it with the original settings. So back to you, Erin.
Perfect. So from here, the next step in the workflow is, getting our quantities, getting our costs, which actually Matt kind of just did that step, generating output sheets and chatting a little bit about how we can export this. So let's go take a look at quantities and output.
Perfect. Oh. All right. I'm sharing the right screen, aren't I?
You sure are.
All right. I wasn't sure which one I hit, and it's not putting the halo around it. Yeah. So we've largely got the geometry of our site figured out here. And I guess I probably should have too added in a pipe, say there, so we can add in our culverts very quickly. So quick tangent, I should have done this last time. Yeah, and we can mess around with our skew, get that position however we'd like. I'm doing this so I can include it in our quantities. So we've got our mass haul diagram down here tracking our balance. So surplus, deficits, etc. It's not telling us the total volume moved. So if we want just a quick snapshot of that, we can produce a data table. And mine's already set up here that I can see I'm within 600 cubes of balancing. So I've got 9,000 cubes of fill, and I've got 9,600 cubes of cut. My gravel surface here, I've got my material for surfacing. So surface layer 1, if we go up here, this is surface layer 1, so I'm using about 3,000 cubes of that aggregate spec, and then for the just normal capping material for the road, I'm at 2,000 cubes. Now we can produce other data tables. So we'll go up here. I'll just set up one that is a little different. So we can control how frequently we see this being summarized. I don't care about equal intervals. I want anywhere that I've added a culvert. And we'll say, well, I want to see just culvert information, not volumes. So let's go into the group called culverts, and I want culvert diameter and culvert length. So there we are, we've got a summary there. So we've got our quantities. Now the costs, I guess I briefly touched on them in here with this total cost that's being calculated in the Project Explorer panel. If we want a more detailed breakdown of the quantities and the material movement that's going to drive that, we can. So the actual values that are used when tracking that number in the software, they're going to be tracked as OptiHaul volumes. So rather than looking at the mass haul here, I'm just going to switch this over to be something else. Copy OptiHaul to clipboard. So this is the detailed breakdown of all the material movement that is actually happening. And unlike a conventional mass haul, we'll break that down for individual materials. So if we have different materials, it'll track that. So if you want to take a deep dive into where all those costs that I just pointed at here, well, you can see that information being summarized in this. Yeah, so we've got costs and then of course outputs. So there's kind of two sides of the coins for outputs. One is if we just want a digital model of what we have here, maybe it's for construction staking, maybe it's to go back and forth with another software, share with the GIS folks, we can hit File, Save As, and we can change the extension to a bunch of different formats. So construction, survey control, land XML is great. Sharing with your GIS groups, shapefile is a great format for that. So again, lots of support for different formats, DGN, DWG, text, etc. To produce a document, we're going to click this button here. So the paper outputs. And I'm going to just say, well, let's go with a size D sheet. And rather than building this out from scratch, I'm going to say, well, let's use our plan profile. So I've got this. Now I can move things around. If I want to change my, well, what's appearing in my sub view at the bottom here, I absolutely can. And we'll give that more room for our profile. And if we want to rotate our plan, we absolutely can here as well. So I can scroll, I can move it around however I'd like. And of course, if it was a longer design, we get to have that on multiple sheets. It'll follow your alignment for you. We'll add in another chapter. So that other chapter is going to be the cross section in this case. And once again, I'm going to just play with some settings. I want to see things rather than every 200 meters, which is pretty sparse. I'll go every 10 meters and anywhere that we've added a culvert. And let's leave that as is. We can cycle through and we can see those cross sections being generated very quick. And of course, you can change logos, move things around, or you can build this out entirely from scratch if you want to start with a blank document. So I think we've got the quantities, costs, and outputs covered, and
Awesome. So that's sort of the end of the workflow segment that we've got, but we did want to kind of include a bonus section. So it is possible to do everything that we just did without the optimization side of things. So we're going to show you a little bit more of the manual design and click in a segment or two here by hand. So before I pass it back to you, Matt, I did just want to highlight as well one other resource, and we'll be sure to include a link to this in our follow-up email to attendees, or for those of you watching this on YouTube, we'll put this link to this playlist in the video description below. And really, it's a full, even more detailed workflow. We created it as a playlist. It's up on our YouTube channel. We'd go through a much larger project. I think we did about 5.5 kilometers of roads, 6 turbine locations without any time adjustments. And I think the whole thing takes about 2 hours, but broken down step by step with even more detail. So we'll include that resource link in the follow-up email as well as below. And with that, Matt, back to you for the last time here before we jump over to some questions.
All right, perfect. So we've got our alignment and pad figured out for the first site. Of course, at the backbone of all this stuff, we still have the conventional design side of the software. So something like this where we've just got a series of short pitches on relatively flat ground, well, we can quickly just design it. And once again, I'm going to just switch my template over to be that wind farm template. And with this, that reference feature is going to be set relative to your current alignment. So I'm going to just come in here and we're going to set that to be that. There. So we'll go, there we are. We'll apply it to the whole thing to start. So I want to snap there. And we'll come out here. And it's fairly blunt 9, so I'm going to roll with what we've got. Whoops. Now, one thing worth noting here, that's going over to that side of my pad. And all the reason for that is I've just got this set to search for that pad within 100 meters. So I could either change that number, or in this case, well, I'm just using my default, or not my default, but my resource road. So I'm going to assign my resource road template in for the first 120 meters. We'll add in our curves. So we'll go in here and I'm going to use the default curve for a lot of these, but just for the sake of doing something different, of course, you can add those values in to be whatever you'd like. And I guess I might actually end up with something very close to that default curve anyway. So we can mess around with that. We could pull it around if we expected to need to. We'll cycle through here. We'll just apply the default. And same thing here. So relatively benign. We're up on the ridge. Same thing as before, though. We want to make sure we don't have anything crazy going along with our grades. So designing by hand. And I'm going to turn on my mass all for this. So keeping track of where I'm at-ish. So then we're right back into this other pad right away. So not worrying about my curves yet. And it's going to be a difficult one to balance just with all that balance by hand, with all the extra earthworks required for the pad, figuring out where things should be. Yeah, so actually I want to be further into the slope here. I don't want to, just kind of have to be. So two things are happening here. One is it's going to be tedious and I'm going to end up just optimizing it to save time. But ultimately, aside from just saving design time, it's going to save a bunch of money. So let's try and get it somewhat closer to balancing anyway. All right, kind of. And I'm going to add my curves. And I won't do that for the rest of these because it's going to be kind of a drop in the bucket for volumes. But we are going to take what we've just done by hand. We're going to click recost. So I've got a big number here. Now, if I was actually designing this by hand, I'd spend more time. But let's take this and we'll create a new vertical alignment. Largely repeat the steps of what we did before. I'm going to just take a note of when my pad start and end. So we're going to go from, say, 290 to 470. So when these settings are applied by station, we'll call it 540 to 720. And we'll go from 920 to the end. So back over here, we'll set those grades to match what we'd like for the area that's not in pads. And then we're going to add in the constraints of 2 and 2 and linear from 920 to
470.
Yeah.
I made some notes for you.
I appreciate that. I have a piece of paper next to me that is just covered in chicken scratch. So, and we'll go 920 to the end. So we've got that in there. Oh, I'm going to add a control point at the start. And we'll run this optimization. And we'll see how that compares to that alignment that I the vertical alignment that I quickly clicked in by hand. So.
And while that runs, I know we're approaching the end of our webinar time, but we're probably going to have a couple minutes to maybe answer 2 or so questions. So if you have a question, we're going to pick the best ones off the list. Please feel free to type it into the question section of the GoToWebinar panel. You are anonymous when you ask. So yeah, type your question. We are going to tackle the 2 best ones from the list.
Cool. And that's done running. So we can see it's the mass haul isn't going up to 25,000 or whatever I had, and we've shaved off about 100,000 from doing the vertical by hand. At a glance, it might look like, wow, we're really high, but we're also dealing with this massive amount of fill that we're generating right there. So it's fairly benign ground, but of course, benign ground on a big area adds up quick. So we're flopping our cut into the fill and just tracking as best we can and working within the constraints that we have. And with that, the rest is all the same. It's just a matter of outputting whatever you'd like. So I think we're at the questions phase.
Excellent. Okay, so the first question we're going to tackle kind of goes back to how you put the pads into terrain. So it says, how did you define your pad geometry in terrain?
All right. So, I guess I'll open up what I have here. So for me, I find it's usually a lot of these pad geometries are reused over and over again and kind of similar. So rather than defining them each time, I've got a train file. So just a standard train file like we were building our tin in. I've got a train file where I've got my pad geometry defined, and I've got my turbine location. So I just move that around as you guys saw. Well, if you don't already have a terrain file, there's kind of, well, a few different ways you can do it. One is if you have it in another format, like I mentioned before, we're great at supporting a wide variety of data. So if you have a, say, DWG, DXF, bring that in. You don't have to start from scratch. If you don't, well, we can, at a really coarse level, we could just draw something in. We could just arbitrarily draw in a box, and I'm going to do that really lousily. So of course, something like that, usually if you're using some predefined geometry, you're not just eyeballing it and clicking it in by hand. So if you would rather have something set up to match some predefined dimensions, well, I've clicked new feature. When I click new feature, I click create using mouse to just set that anchor point wherever I'd like. But I'm going to modify it, and I'm going to use, well, I could use coordinates. So if I wanted to just base it off 0, 0, 0 and work that way, I could. Or I could do it based off survey format. And rather than doing anything complex, I'll just do a quick box. So if I want it to be 100 by 100, I'll go 0 azimuth for 100 meters, then I'll add in another leg. I'll change the azimuth to be 90, and I'll add in another leg. I'll change that to be 180 and modify, close. So it's pretty easy to build out that geometry. However you like, there's different tools to do it. So, and it doesn't have to be in a scratch file either. If you had something that you wanted to consider in your terrain file and draw that in specific to the site, you can. Now I didn't have contours here, and another thing that I didn't do here was include other information for context. So we could absolutely reference a ortho, bring that in and see where things land as we're defining where we'd like to put things. So yeah, hopefully that answers the question. A little bit of a tangent with the ortho stuff, but
Awesome. Okay, let's do one more question and then we'll wrap it up. So the next one, let's just kind of keep on the topic here of pads, pad geometry. What happens if I need to move a pad location? Do I need to redo steps?
well, I'll hit save here just so it shows up. You'll probably have to move something and redo some of the steps, but it's nothing set in stone. It's not, by any means, it's not going back to square one. So I'll be cheap. I'm going to go with the one at the end here because it's going to be less going on. So if I take this and if I decide, well, I actually want that to be rotated further over here, realize my approach isn't nice, and I'm going to be falling off my tin. I'm going to have to just move that a little bit just so we have enough room to play with. So I've moved that. I'm going to hit save. That's not a super tiny file, but it's going to prompt you once it saves that it's been modified. Do I want to load them? Well, yes, I do. And well, suddenly having the road on this approach doesn't make sense anymore. So we will make it make sense. So your short answer, you are redoing steps. You're adjusting your horizontal alignment to match that. But it's still fairly dynamic where you can pull that around and things will update the updated file. One thing I'll do is redraw so we can see that. And then here where that changes the approach, we're probably going to want to redo our vertical optimization as well. So it changes the problem a fair bit by moving where you're going to, but it's easy to capture. And we did 4 turbine sites here in an hour with a bunch of explanations. So it's you can explore a lot of different scenarios really quickly as well.
And with that, 2 minutes over. Thank you everyone for attending our webinar today. Hopefully you learned a little bit more about the workflow inside of RoadEng for preliminary as well as detailed wind farm road network design. We will send out a follow-up email sometime later today once marketing gets it out. It'll include a link to the video as well as a link to that playlist of extended videos that we have available up on our YouTube channel. For those of you who asked questions that we didn't get to, we'll follow up over email. They were great too, just not quite as great as in my opinion. And with that, thank you guys. We'll see you next time.